Are there any examples of different philosophies of probability yielding different calculations? It seems to me that, mostly, philosophies of probability make differing interpretations. But they don't yield different probabilities, i.e. numbers. I can partially answer my own question. I believe if someone said something like, the probability of Ukraine winning the war is 50%, von Mises would reply that there is no such probability, properly understood. He thought a lot of probabilistic language used in everyday life was unscientific gibberish. But are there examples where different approaches to probability yield distinct numbers, like 0.5 in one case and 0.75 in another? A philosophy of probability is only going to impact how the calculations are done if it can be coherently translated into the math. If von Mises thinks that such a probability doesn't exist, then he simply wouldn't do the calculation. Metaphysical theories of probability are unlikely to make a difference if their core concepts can't be expressed mathematically in a way that is consistent with actual probability theory. In probability theory, the two dominant paradigms are the frequentist and the Bayesian. They are not generally referred to as philosophies, but they can certainly be interpreted that way. The frequentist paradigm defines probability as the number of occurrences of an event assuming that you can draw a random sample infinitely number of times. This makes sense, for example, if you want to calculate the probability of drawing a spade from a deck of cards. It makes less sense if you want to calculate the probability of Ukraine winning the war. You can't create an infinite number of Ukrainian wars, let alone with the exact same conditions, and see how many Ukraine wins. The Bayesian paradigm is built off Bayes' theorem, and at its core it's about making subjective probability explicit in the math. For example, based on your experience as a geopolitical analyst, you might judge that Ukraine has a 60% of winning the war. You would then explicitly state this in your model. Both paradigms emphasize calculating probabilities using data. The more data you collect, the better. This allows the frequentist to update their calculations, and also for the geopolitical analyst to update their beliefs over time. Bayesian and frequentist paradigms can lead to different probabilities, but can also be shown to yield the same result under certain assumptions. Any new philosophy of probability is unlikely to make significant differences from the other two paradigms. This is because probability theory is well established and robust, so we would expect any new perspectives to be consistent with them, at least under certain conditions. The boy or girl paradox, or two children problem, leads to different outcomes depending on the phrasing. Which leads to the question what we mean when we talk about probability, and how probabilities should be understood. As others have mentioned, the Sleeping Beauty problem. Another famous case is Bertrand's paradox, aka, what is the likelihood of a chord in a circle being longer than the length of a side of the inscribed equilateral triangle? One approach yields 1/4, another 1/3, and a third 1/2. 73.4% of statistics are made up on the spot. When someone says that there is 50% chance of something happening, there's a 99% chance that they are just making it up. Seriously though, there are different interpretations of probability, which lead to valid probability analysis that depends on underlying assumptions. The probability calculations would strongly depend on those assumptions, and have to be taken as reasonable bounds for analysis and understanding. Simple assumptions like ergodicity are very often knowingly false, but used anyway to be able to make a reasonable estimate. Take for example the Drake equation. It makes no assumptions on its own, but sets a clear framework for studying the probability of an unknown event. No. Anything that can be calculated can be tested. And once you can test something, there's only one right answer, and your theory either gets it close, or it's just wrong. No room for opinions or different schools of thought, though in something like macroeconomics, or whether Ukraine can win, you have lots of estimates and assumptions of both fact and theory that we lack the science to speak of with certainty. So there's lots of room to make wildly inaccurate estimates that will throw your probability calculations off. And more importantly, as the old joke goes, 87.65% of statistics are made up on the spot and were never calculated at all. Just someone spouting their arbitrary estimate of how certain they are in their gut feelings.
Don't forget to like and subscribe so you don't miss our next exciting video.